So use the grids to create the graph of each linear inequality below. Real quick, before we actually do this, we made a little T-chart. So I want you just to draw that up here so you have it handy. We said solid and dotted. We said above and below. And this just lets you know what kind of line goes with which kind of symbol and where we would color, right? So above is going to be greater than, below is less than. And we said if it has this extra or equal to line underneath, that's going to be a solid line. When we look at these two graphs, it says list the coordinates that represent solutions to both inequalities. All right, well, we're going to graph these inequalities first. We said yesterday you're going to graph it just like you would graph y equals mx plus b. So we'll start at our b, which is 6, and our slope is down 1 over 1. And you could do that a couple of times. If you have a ruler, you could use that. Is this going to be a solid or a dotted line? Solid. It has that extra line underneath, right? So here is my solid line. Are we going to shade above or below? This is below.
Is this what we need our colors for?
You can use your colors to shade it, yes. So this second one, very similar equation. The signs are a little different, so be careful. So now we're going to start at -6. This one has a positive slope. Rise 1, right 1, rise 1, right 1. What kind of line is this going to have? This is a dotted. There is no line underneath. And where we're going to color it?
Above.
We're going to color it above because it is greater than. So if we look at number 1, list 3 ordered pairs that represent solutions in both. So give me some coordinates that would be in both of these shaded areas. One of the ones we talked about yesterday was the origin. Is the origin going to be a solution to both?
No.
Yes. They're both in the shaded region. So we're here and we're here. Let's see, is 1, 1, here is in the shaded region, here it is in the shaded region, very nice, 1, 1. Is there another one? 2, 2, sure, why not? All right, we'll just keep it easy. Is 6, 0 a solution to both? All right, so where is 6, 0? I'm going to change my color to green for this one. 6, 0 is here on the x-axis. Is it a solution? The key word here is both. No, why not? Right, so it's only on the first one. Only a solution to the first. Only to the first. Or the one I did in red, right? We said if it's on a dotted line, it doesn't count. Only if it's on a solid line. If the inequalities were graphed on the same coordinate, how would you identify the solution set to both inequalities? So that's what we're going to work on today. It would be where the colors overlapped. Okay, and that's why if you want to use color pencils or a highlighter, you can see those colors pop out at you. So a system of inequalities is going to be a set of 2 or more inequalities with the same variables, right? So we have x's and y's. We're not using, x and y on one and a and b on another. The solution set to a system of inequalities includes a set of ordered pairs that make all the inequalities true. So just like before when we would plug in the xy coordinate to the system, it needs to say true in your calculator for both. When graphing a system of inequalities, the solution set is represented by the intersection or the overlap of the shaded or the colored regions. When we graph this first one, I'm going to use red for that. So just like we did in the 2 at the top, We're going to start at 2. Our slope is rise 2, run 1. Is this going to be a solid or a dotted line? This is going to be dotted. Are we going to shade above or below? Below. Very nice. So here's my dotted line. Make sure I can tell that it's dotted. And when we color below, it doesn't have to be fancy or anything like that. If you're just using a pencil, you might just want to lightly shade in one direction. For this second one, we got to start down here at -3. And our slope is negative, so I'm going to go down 1 and right 1. Down 1 and right 1. I could also go up 1 and left. Is this going to be a solid or a dotted line? Solid, above or below? Should be above, yes. So here is my line. When I color this one above, red and blue makes purple. So where you see the purple, that is actually our solution set. Okay? So I could even go through and I could erase, because we're only looking for where it overlaps. You don't have to erase on your paper. I just want you to kind of see what that would look like. Okay? Or I could even make it darker. All of these coordinates in this colored overlapped area, that's where all of our solutions are. To include on the solid line, but not on the dotted line. So the second part of this is, are any of these coordinate solutions? So if we graph them, here is 0, 0. Is it in the overlapped shaded area? Yes, it is a solution. We could put 0 in for y and x into both of those inequalities, and it would tell us true in our yellow calculator. For -3, yes or no? Yes. It is in the overlapping area. What about -2, +3? No, that was only in the blue. So that is a solution to the blue inequality, but not the system. When we look at this one, again, we're just going to graph like we normally would. This one doesn't have a B, so we're going to start at the origin. The slope is 1/2, so you're going to go up 1 and right 2. Is this a solid or a dotted line? Solid. It has a line underneath. Above or below? This is going to be below because it's less than. Now, some people don't like to do their coloring. They like to wait and color at the end. If that's you, that's perfectly fine. Me personally, I'm like, well, I'm going to kind of color and see what happens. This one, what's wrong with this second one? We can't graph it like that, can we? We need to change it to what? Y equals. How am I going to do that? Subtract the x. I did not divide by a negative, so I can start down here at -4. My slope down 1, right 1, or up 1, and left 1. Is this a solid or a dotted line? Dotted, above or below? This one is also below. So here's my dotted line. When I color this one below, all right? So right here, this bottom quadrant is going to be my overlap, okay? Now, again, on the dotted line, that is not going to be a solution, but on this solid line, yes, those would also be included. So when we look at our coordinates, again, we can just graph them. 0, -4. What do you notice about that? What kind of line is that on? That is on a dotted line. Is that a solution? No, only on a solid. -3, -6. Yes, it is. And -5, 0. No, that's only in the blue. What do you know about y is greater than or equal to -6? There's no x, so the slope is what? This is a horizontal. This is a oi. So it's a horizontal. Is it solid or dotted? Solid, above or below? above. So let me change this so we can see the color a little bit better. -6. Here's my horizontal solid line. You can color above. I'll show you what it looks like when you wait to color. If you're going to use this second one, we got to change it again to y equals. So what do we do first? Minus x. What happens with this 2? We divide everything by 2. Now, we did not divide by a negative, so that inequality is still going to be a less than. 4 over 2 is 2. My slope is a -1/2 x. So now we're starting up here at +2. We're going to go down 1 and over 2. All of those skills that we've used in graphing are really going to be coming in handy. Is this a solid or a dotted line? Dotted, above or below? This is a less than, so it's going to be below. All right. So we know below is down here. I'm just going to put some little dots so we can see it if we just wanted to color one part. And we said this one was above as well. So you can see our overlap is going to be here. So this is just our shaded region. So if you don't want to do 2 colors, I would make a little, like, I use the dots to kind of see where I need to be looking. And there is our overlapping shaded region. That's where all of our solutions will be. We're going to write a system. We're going to have to look at the different lines. So we have a solid and we have a dotted. Which one would you like to do first? Let's look at that. Okay, the solid I heard. What do you notice about that? It's a what? It's a hoy, right? So we know it's going to be y equals horizontal, 0 slope, y equals what number is that? Look at your scale. Be careful. 6. Y equals 6, but it's not an equals. It's a solid line, so we got to put our or equal to underneath. And where is it shaded? Do you see where it's darker? It's actually shaded below. Look at all the shading down here. So is that less than or greater than? That is going to be less than. This one is going through the origin. So if we count our slope. So when we count this slope, remember it's counting by 2s. 2, 4, 6, 2, 4. So 6 over 4 is 3 over 2. So we have y, we have 3 over 2x. This is dotted, so no line underneath, and it is shaded where? Above, so greater than. Okay? We know how to find the solutions that are and are not on the system. So on this one where you're listing the solutions, you're looking for any coordinates that are in this overlapping shaded region. That's going to be a solution to both. Now, we also talked about it can be on the line. So give me a coordinate. You could use what? -4, +2. I like that one. That's a good one. So you can see right here, -4, +2. What about 0, 0? No, it's on a dotted line. What about 0, 6? Yes, it is on the solid line. And then we can pick one more. -8, what? -8, 2. What'd you say, Jake? -6, 0. So there's 4 of them. So if they are not solutions, they're going to be anything that is outside of this shaded region. So, anywhere within this yellow or on this solid line. So we could say 0, 0 is not a solution because it's on the dotted line. Okay?